Hemostasis is the normal physiological response to limit blood loss after vascular injury. Blood clots are made up of activated platelets, red blood cells and fibrin, which hold the clot together. The process is mediated by around 30 proteins, which are known as clotting factors. Platelet activation and aggregation begins when vascular injury exposes collagen and von Willebrand factor from within the vessel wall to the blood. Platelets adhere to these proteins and become partially activated, changing shape and releasing signaling molecules which recruit more platelets to the site. At the same time, a protein called tissue factor triggers initiation of the coagulation cascade, the process that leads to full activation of platelets and the generation of fibrin and clot formation. Vascular injury causes tissue factor on the outside of cells in the vessel wall to come into contact with factor 7A and factor 10A in the blood, leading to the production of a small amount of thrombin. This thrombin fully activates platelets and triggers a cascade of clotting factors that activate each other, culminating in factor 10A-mediated generation of a larger burst of thrombin production on the platelet surface. One molecule of factor 10A leads to the formation of 1,000 molecules of thrombin. Thrombin converts the soluble protein fibrinogen into insoluble fibrin strands at the site of vessel injury, while at the same time activating factor 13 protein to cross-link the fibers. The fibrin mesh stabilizes the clot and traps more platelets and red blood cells, facilitating its growth. In normal physiological conditions, the process of clot breakdown or fibrinolysis begins as the structural integrity of the vessel wall is restored. Endothelial cells begin to secrete a protein called tissue plasminogen activator, which activates the protease plasmin to degrade fibrin, dismantling the structure of the clot and restoring the integrity of the vessel.